Today my topic is Appel reaction. This is one very important reaction by which primary and the secondary alcohols react with triphenyl phosphine PPH3 and carbon tetrachloride CCl4 or carbon tetrabromide CBr4 to give alkyl halides under mild condition. This reaction proceeds through inversion of configuration at the alcohol bearing center. Now overall this reaction is an example of the SN2 type of reaction which proceeds through Walden inversion. Now coming to the mechanism of this reaction, the first, the CX4 means the carbon tetrahalide reacts with triphenyl phosphine to give one salt which is known as Appel salt, and CX3 minus. In the next step, this CX3 minus abstracts the H plus from alcoholic OH and we get conjugate base of alcohol and haloform. Now we are proceeding to the next step where the conversion of the O minus of conjugate base of alcohol becomes one effective leaving group. Now how it is becoming effective leaving group? Now Appel salt, which was formed in the step 1 of this reaction, interacts with this conjugate base of alcohol. I mean the O minus attacks the P plus of center of Appel salt, and we in this way this O minus gets converted into one effective leaving group. Now this is resonance stabilized oxonium ion. Let us proceed to the last step where the nucleophile X minus attacks that oxonium ion from the back side, so that Walden inversion happens and we get the alkyl halide with the byproduct triphenyl phosphine oxide. Now this there are various examples by which that alcohol, primary alcohol and as well as the secondary alcohol can be converted into the alkyl halide, mainly chloride and the bromide. And if that center is chiral, in that case this reaction, Appel reaction, proceeds with the inversion of configuration. Now let us discuss one example where this concept can be applied to convert one. When the Appel reaction is applied to the hemiacetal alcohol of carbohydrate, then it is getting converted into the halide, and leaving group is oriented in the equatorial way, so that at the last step the halide attacks from the axial side. So finally the product contains axial alcohol. Now let us apply Appel reaction to the various primary and the secondary alcohols in order to convert it into the corresponding halides. The benzyl alcohol can be converted into the benzyl halide. Cyclohexanol can be converted into the cyclohexyl halide. If that is OH containing center is a chiral center, in that case that halide will come in the opposite side. I mean, if OH is above the plane, means OH is on the beta bond, then halide will come in the alpha side, means the below the plane. Now we successfully, this example, I mean that Appel reaction can be applied to the natural products also. So now see it can be applied to the menthol as well as the geraniol, where menthol contains the secondary alcohol. With the inversion of the configuration, Walden inversion happens and the halide comes into the opposite side and we get the methyl halide. In exactly similar way, geraniol is one naturally occurring molecule where we have the primary alcohol, and this primary alcohol gets converted into the geranyl halide by following this Appel reaction condition. Now in this context I would like to mention one very important thing. Suppose if there is no alcohol, while performing, if somebody forgets to add the substrate and they continue this reaction by adding triphenyl, phosphine and CX4, in that case what happens? Now in that case also means in absence of alcohol also triphenyl, phosphine and the carbon tetrahalide, they react and we get some compound in absence of alcohol. Now coming to the another complementary reaction of Appel reaction, means suppose we want to convert one chiral alcohol to the halide with the retention of configuration. In that case it is clear that Appel reaction will be of no use, because Appel reaction proceeds through the inversion of configuration at the OH bearing chiral center. But now if we want to convert that chiral alcohol to the halide with the retention of configuration, then what to be done? In that case, alcohol should be allowed to react with the thionyl chloride in presence of pyridine, and the reaction will proceed through the retention of configuration, and in that case obviously the mechanism is not SN2. This conversion with the thionyl chloride in presence of pyridine, reaction proceeds through the SNI, means the nucleophilic substitution intramolecular, which proceeds through the same side attack. Now coming to the application of this Appel reaction in a very complex natural product with so many chiral centers, but the advantage of this reaction is usually because of the mildness of this reaction, side reactions, rearrangements, all these things usually do not happen at the low temperature. So this reaction proceeds through the primary alcohol or the secondary alcohol. If there is one chiral center with the OH bearing center, then it proceeds through the Walden inversion. Now coming to the highlights of this reaction, this is a very important reaction in organic chemistry. It has a tremendous application where we need to convert the chiral alcohol with the inversion of configuration to the alkyl halide. Now this related reaction is, the Mitsunobu reaction also is useful to convert the alcohol to the alkyl halide, but their reagents are different. Now in comparison with the CCl4 and the CBr4 gives what it is called, the reaction will be slightly better. This reaction condition is a simple, mild and neutral condition, so it is very popular, and this reaction proceeds through the high yield. And usually under the Appel reaction condition, if it is performed at the low temperature, then allylic rearrangement do not happen, but under reflux condition, if there is a suitable environment, then it may undergo the some rearrangement in order to get the corresponding alkyl halide. Thank you.